Alright, next section is going to be section 6 in our prerequisite chapter. It's about rational expressions. Before our next assessment, we will go over 3 sections from the book, and I believe I'm going to split that into 7 videos to kind of make them smaller, more manageable parts. So today we're going to talk about domain, and more importantly domain restrictions, and then how to simplify, multiply, and divide rational expressions. So to start, we need the definition of a rational expression. We're just going to call that the quotient, or a quotient of 2 polynomials. And our domain then is all values, or all real numbers, of which makes that rational expression defined. Now when we talk about domain, this is the big piece, and we're going to use this all year. We need to worry about 2 cases. Anytime we divide by 0, we get a problem. And anytime we have radicals with an even index and a negative number in particular underneath, create problems. So if you think about something like the square root of x minus 2, we have to worry about values of x that would make this negative, and so we'll have a range of numbers in that case. For division by 0, it's usually strict down to 1 or 2 or 3 numbers that we're going to exclude in particular. So an example of that, and here I don't have any index or radicals in the denominator. Mostly in this chapter it's not going to be any radicals, because remember they are polynomials. But we do need to worry about division by 0 here, so we want to look at our denominator and say, when is our denominator equal to 0? In this case, if I add 2 to both sides, I know my denominator is equal to 0 when x is 2, which means we can't do that because we can't divide by 0. So we would say our domain is all real numbers, and there's your symbol for all reals, except 2. Okay, for this second one, we need to be careful because we actually need to make sure that we factor our denominator first. So this is a difference of squares that we did last chapter, and it would factor like that. So here it would tell us that x cannot be 1, and x can also not be negative 1. So our domain, we would say, is all reals except 1 and negative 1. That would be our domain for this one. Okay, simplifying rational expressions, and the way we're going to do that, first off, start by factoring your numerator and denominator completely, and then you are going to cancel out any common factors that are in both the numerator and denominator. So if we look at our first example here, I can take out an x squared in my numerator, which leaves me with x squared and x plus 1, the whole thing over x plus 1 still. Which means now we can cancel out common factors. The x plus 1's cancel out, and end up with x squared. One thing we need to be careful about when we start talking about domains is you need to do your domain first. So the domains for this one would be all reals except negative 1. Okay, so we could say all reals except negative 1. Here, if we're going to factor both, so factor in the numerator like we did last chapter, products or factors of 5 that add up to 6 are going to be x plus 1 and x plus 5 all over, this is a difference of squares again, which we just saw in the last section and last slide, so x minus 5 over x plus 5, which means we cancel out our x plus 5's, and so we have x minus 1 over x minus 5. Again, our domain then is going to be all reals except x cannot equal 5 or negative 5. Okay, so that is simplifying rational expressions in order to multiply rational expressions. First thing you're going to want to do is still factor your numerator and denominator completely, just like the last one. Cancel out any common factors, just like the last one. That's going to make things a lot easier as you go along. Then, just like multiplying normal fractions, you're going to multiply the numerators and multiply the denominators. So here, if I factor this, first, I'm going to leave the x minus 7 over the x minus 1 alone. Times, if I factor my numerator, I have x plus 1, x minus 1, over 3, I can factor out of the denominator, x minus 7. Which, the nice thing here then, since we have an x minus 7 in the numerator and the denominator, I can cancel those out, and an x minus 1 in the numerator and denominator, I can cancel those out. So in this case, our multiplication actually simplifies out pretty easily to x plus 1 over 3. We can't always cancel out so easily. The other thing to be careful about is just because we have an x in here doesn't mean that it cancels out with just an x down there. You need to think of things in terms of quantities. When we're multiplying, put more parentheses around, like even here we could have some parentheses. Okay, last big objective for today is going to be dividing rational expressions. So we divide rational expressions. We essentially do the same thing as multiplication, except for we want to invert our divisor. And when I say divisor, what I mean is whatever we're dividing by. So once we invert, we're just going to multiply. So first thing I'm going to do is factor that numerator. So that's going to become x minus 4 and x plus 2 over, I'm going to factor the x squared minus 9 here into x plus 3, x minus 3. And then I'm going to multiply, so instead of divide, I'm inverting my divisor. So I get x plus 3 over x minus 4. And once I invert my divisor, then I can just follow my multiplication process, which, remember, starts by crossing out anything in common. And it may help again to put these parentheses here, because we have to cross out quantities. So the x plus 3's will cancel out, and the x minus 4's will cancel out. And we're actually again left with just x plus 2 over x minus 3. And now it's not always going to cancel out so neatly that you don't have to multiply anything on top. Sometimes you will have to multiply things on top. So that is it for this video. We did division, multiplication, domain, and simplifying. I think you'll probably notice the big thing from this video was that we had to factor in every single type that we did. Simplifying, multiplication, division, we factored in all of them. Domain is also typically a thing that gives us a problem. You need to be aware of two things there. We can't divide by 0, and we can't take a radical of an even index of a negative number. Okay, we'll see you next time.